Yes. What could possibly be coming? Yeah, sure. Désolé, je ne parle pas français, sauf pour cette phrase, cette deuxième phrase. So sorry, I won't try any more French, I promise. So we're here for the State of Python Tooling. My name is Jason Carver. I'm a Web3 Pi contributor, and we're going to be talking about a whole lot of the state of Python on Ethereum. This was my first title. I'm not good at titles. It's a brief, incomplete skim across the surface of Python tooling on Ethereum because there's way too much stuff out there to cover, so my apologies in advance for the many things that I'm leaving out. So before I get to exactly where we are right now, I figured we should start with where we ought to be, where we'd like to be. And so I think this XKCD comic really captures where what I love about the best Python libraries that are out there, that you can just import anti-gravity and fly. So that's where I think we ought to be. Before I continue on, if anyone is tempted to take pictures during or worried about getting slides, this is a QR code to the slides as well as a URL for it. So I'll pause for just a second for anyone who wants to grab that URL or QR code so that people can be engaged here. All right, looks like we are almost wrapped up. OK. So what does import anti-gravity mean for Ethereum? So we'd like a whole ecosystem of tools that are Pythons all the way down. So we want to be able to import feature libraries that do exactly what we want. Those feature libraries should probably be depending on underground libraries that do one thing well. And we want it to be Python all the way down so that we can hack and understand the whole stack. So a brief list of some examples of things that we would like to be able to do with Python. So if your transaction is stuck on mainnet because your gas price wasn't high enough, it should be a one-liner to bump up the gas price of a pending transaction. It should be quick and easy to open state channels or make payments or verify payments, micropayments across them. We might want to use hardware wallets to do all of the things. And we want to easily verify contract sources locally. So go a little bit more into each of those further on. So how close are we? Unfortunately, not too close. We have a little ways to go, but we're on the right path. So there's a lot of things to work on. Of course, we can't work on everything at once, so we'll just pick out a few things to talk about that we think will be most impactful first. So we've got the node interface, non-hosted keys, verifying contract source, and an all Python node. These are things that we think will have the most impact early on, and I'll go into each of them in detail here. So we'll start with the node interface. So what I mean by the node interface, for people who are perhaps just getting started, a quick reminder of a simplified version of how the stack works. So if you've written a dApp where people can visit in a mist, that dApp then talks to the Ethereum blockchain over Web3.js. So it imports Web3.js, which then uses the JSON RPC API to talk to your node, maybe gather parity or something else. And then that node, of course, connects to the rest of the network for broadcasting your transaction or retrieving the data or whatever. So what does that mean for Python instead? So essentially the same practice here. So we've got, instead of Web3.js, we've got Web3 Pi. And your Python app is written on top of that. So when we talk about the node interface, we're talking about essentially everything that you want to do with the network itself is going through Web3, and so that is your interface to everything. So it seems like a good place to start if there are any problems there. There are a few things that are pretty rough around the edges. So What's weighing us down? Lots of things. Here's a couple. Currently, Web3 Pi is in version 3 stable right now. So this is, when I say what's current, that's what I'm talking about, the stable version. Simple things, typos in destination addresses is going to cause an unrecoverable loss of funds. You mix up an A for a 4, and it's just gone. Deciding which gas price to use. It's tricky enough-ish when you're doing it manually, but if you have a long-running script, you better be pretty good at automatically picking a gas price, or you're going to end up with a lot of either overpaid transactions or transactions that get stuck pending. Integrating to, using contract calls without hosted keys, that'll make a little more sense in the next session, or the next section. And the data types were not very standard. So, if you were interacting with a contract that returned bytes, you were getting a string back that was hex encoded, and sometimes it was expecting when you were sending bytes to send encoded bytes. It was unpredictable. So that is the current state of Web3 Pi. So some examples of things that are changing going forward in version 4, which is out in beta right now, is when you're sending transactions to an address, you can also send transactions to an Ethereum name service address. So this will be a bit more obvious if you have a typo in a name. Of course, there's still phishing attacks and things like that, but it's certainly a lot easier for a human to spot a letter swap. In addition, checksum addresses are required everywhere in version 4 of Web3. So that means that you should be looking for other services that return addresses in checksum format. So we've got a new estimation algorithm coming out. It's inspired and courtesy of ETH gas station info, and rewritten into Python integrated with Web3. Currently, it does quite a bit of work, so there's a trade-off there of how quickly do you need to send this out or do this estimation. Because it might take you, a number of seconds, 10 seconds or something, to run an estimation, because it hits a whole bunch of recent data to do it, and it does it all on the fly right now. So I'll skip over the contracts, and whenever you interact with a contract that's got a type like string or bytes, it's going to give you back that natural native type in Python. So that means, if the contract returns a string, you get a Python stir. If it returns bytes, you get Python bytes. It's worth spending some time, if you're not familiar with encoding back and forth between string and bytes. This is absolutely critical to understanding and working with any raw binary data. Is knowing ahead of time what encoding it was in. So all these things are in version 4. They're coming out soon-ish. So there's a lot more coming as well, but not enough time to cover it. So node interface definitely has some things to work on coming up soon in Web3 Pi. So let's talk about non-hosted keys. So some quick definitions, at least how I'm using them today. So local keys versus hosted keys. Hosted keys are kind of the traditional experience of starting up your own node and generating an account. A local key, for people who haven't dived into this, essentially is really just 32 bytes of random data. So you generate your own 32 bytes of data and keep it somewhere very, very safe. So if you have a local key, if it's stored in your app, it's a local key. If it's stored on your node, it's a hosted key. Which also brings us to the importance between sort of a local node and a hosted node. And by hosted, I mean someone else is controlling it, so like an Infura, versus a local node where it's completely under your control. If anyone has access to your node, it's hosted by this definition. So a hosted key on a local node is your traditional case that I covered. Get the parity, create an account, and then you can send a transaction. Now, if you're using a hosted node, you can't just tell Infura to, hey, go send a transaction with my account, you know the details, because they don't host your private key, which is a good thing. So you have to do all of the work locally. You have to sign the transactions and give them the raw signed transaction. So that would be using a local key with a hosted node. And since we're enumerating options, a hosted key on a hosted node should never, ever happen. If someone's offering that, they're scamming you, or either by intentionally or by accident. Don't ever do this. And then a local key on a local node is kind of trivial combination of other things. So what's kind of holding us back in this space of non-hosted keys of local nodes? A lot of Web3.js and Web3.py both have been focused on the use case of your node has your key. So you just give your node the information about the transaction you want to send. Here's who I want to send it to. Here's the value. And your node takes care of packaging that up, signing it, and broadcasting it. Which means that Web3 doesn't currently have a lot of good support for working with local keys, where you would have to locally do those things of packaging up the transaction, signing it, and handing it off as a raw transaction. So, the options for working with local keys mostly are MyEtherWallet or MyCrypto. I guess those forked recently. I don't have any, favorite horse I'm betting on there. That's pretty good for manual tasks, but obviously it doesn't help too much with programmatic ones, especially in Python. So it's very difficult to do things like work with local keys to broadcast a transaction that you sign locally. It's difficult to work with state channels. It's difficult to do kind of authentication that you might want to do, such as maybe your web server wants to authenticate using someone's Ethereum account, so you give them a message to sign, they send it back to you signed, and you can verify it in your Python server like Django and say, okay, I know you control this account without having to actually submit something on the blockchain. So all of those things are a little tricky to do right now, but upcoming solution in beta is a package called EthAccount. This is a library that is essentially built to do all of these things, signing and verifying transactions and messages, trying to be as minimal an API as we can support and still be useful. This is ready for, it's essentially API stable right now, pending security audit, so not ready for production use. But that's scheduled for this month, so we're optimistic it'll come out soon. This will also be wrapped into Web3.py. All right, so verifying contract source. In a lot of ways, this is the promise of Ethereum, the quintessential promise of Ethereum, in my mind, of being able to know that that the code that's running is the source that you read, right? It's kind of like the next step of open source, where in desktop open source, you could download source and compile it yourself, and you know exactly what's running. You can't do that well with hosted services. Of someone just promises they're running a open source server. You can't really know that for sure. So Ethereum kind of enables that, right? It gives you the ability to see the source that's running among everyone on the network. But in order to do that, you have to actually be able to say, okay, I read this source, I personally verified it. Is that actually what's in the blockchain? And that's not trivial, especially right now. Because unfortunately, the best answer we have right now is go look for this check mark on Etherscan to decide if it's really validated, which is terrible. This should not be the state that we are targeting. I mean, it's great that Etherscan offers this service because it's the best thing we have. But we shouldn't, the whole point is we shouldn't have to rely on third-party trusted sources for these things. So why is it that we're in that state right now? There's a few things that are difficult or that are required to actually verify this. Essentially, you have to compile it yourself and then verify the output. But because compilers are finicky, you have to know every single detail that went into it, right? In addition to the obvious things like the source files, you have to know the version of the compiler that was used, the flags, whether it was optimized, and whatever compiler flags you might have on. You have to know which libraries it got linked to, and of course the deployed address. So Etherscan sort of does both all of this and then actually does the compilation and tells you it was compiled in the same way. But we should really have some other mechanism available. And so this is very much in the planning stages. There's a spec out that's sort of under review, and people are thinking about it but haven't gotten a whole lot further. There's something called ethpm spec, and it basically defines a lock file that includes all of these things and some more. You know, it's just a little clip of it here includes things like the compiler version and flags. So this lock file, the idea is that it includes all that information for verification, as well as links to the other libraries that it depends on in the form of a content address linked to the lock file of that library. So you get kind of recursive lock files all the way down, and you know, you post it up on IPFS or whatever content address store that you want. And you can verify. First of all, it's you know, once it's broadcast, you know it's the same thing because it's, you know, fixed data, and you can then use all that information to locally verify. I'll skip the shared repository bit. Okay, so ethpm spec is sort of the eventual upcoming answer to that issue. And then the last thing I want to talk about today is the all Python node. So right now the situation is that PyEthereum is the stable Python node that's available. The prototypes that the research group works on, whether it's, you know, sharding or proof of stake, often end up well, they're almost all in Python and often end up in the PyEthereum code base. And additionally, you know, the network is generally more resistant to things like denial of service attacks and consensus bugs when there are more different kinds of nodes available. So where are we really with that? Well, PyEthereum, unfortunately, is practically incapable of keeping up with mainnet for a variety of reasons, including everything running on one thread with the networking code and the EVM execution and other things, which means that there's this sort of gap between the work that the research team does on top of PyEthereum and actually getting into production. It has to all be re-implemented somewhere else in other nodes. Of course, that re-implementation has to happen anyway, but it'd be nice if we get to at least reuse the research team's work directly. And then, you know, ultimately, there's only two dominant nodes. Last I checked, Geth and Parity are like dominating the network. Now, two is way better than one. We've already had scenarios where one or the other gets knocked out by denial of service or consensus issues. Well, mostly denial of service, and so. You know, the other one was keeping it moving, but it would be nice if we never got knocked down to even one. So the upcoming answer to this is Trinity, which is a brand new all Python node. I shouldn't say new exactly. It's under active development. It hasn't even been released as an alpha yet. This is not an official logo, just a fun image I found online. So the goal for Trinity is to be a viable mainnet node, you know, the likes of Geth and Parity, which is, of course, a lofty goal. So it'll take a while to get there, but you know, right now it is under production and under development, and the research team is already starting to work on top of it. It's you know, it runs some local tests, some EVM local tests effectively, passing them, and it's currently located with the project called PyEVM, which will ultimately be more like the EVM library that any other project could import, and then Trinity will be the node that you can, you know, start up at the command line that takes care of all of the networking and everything else that's involved with running a full node. So that's definitely worth keeping an eye on as another alternative. Even if people are just kind of interested in reading through how does the EVM work, this is a great reference to how execution actually carries out. So, just quickly, a little bit of news. The Web3 Pi version 4 launch is scheduled for the end of the month. Mostly just because I've got a continued European vacation going on as part of this trip. So should be end of the month, everything going well, and so the things that I mentioned should be out quite soon, actually. If you can't wait, then you can install it on pip already with pip pre. So for anyone interested, I've also got a workshop tomorrow. Sort of the idea is kind of a beginner-friendly, interactive workshop where you can bring your own ideas or use one of ours to get started. You know, walk around, see what people are interested in doing, and just kind of turn it into an office hours, help people out wherever you get stuck, and just hack. You know, so no point in coming if you don't bring something to hack on. That's the kind of workshop it'll be. So, just to wrap up, you know, how do we actually overcome gravity? You know, it's not going to be by pure marketing. It's not going to be by like buying and selling tokens or buying and holding tokens. The way that we actually defeat gravity is by building things. So I hope you'll join, contribute however you're interested. Even you know, tell us what you think could be improved about it. Everything helps. And with that, I'll say thank you and ask if there's any questions. Okay. Any questions? Yeah, so GitHub, the Ethereum, yeah, sure. So the question was, where do we find the Trinity project? So it's on GitHub, the Ethereum org, so github.com/Ethereum. And then right now it's co-located with the Pi EVM project. So GitHub, Ethereum/Pi-EVM.
The ETH-PM package, how does it find for a consensus or authority on how do you deal with different source code that can compile to the same?
Right, so this is purely the spec as it is right now. Oh, so the question was, oh, I guess you got the question on, Mike. So the spec is purely a matter of defining a file format. Right, so it's just saying, you know, it includes the compiler version and everything. There's no, you know, once you have all of that information, you don't. So in addition to things like the compiler information, it also tells you which network it was deployed on, right? So once you have all that information, there's no more trust involved. You can do everything you want to do locally because you can get the code out of that network address, and then use the sources that are linked in the lock file and use the options that are linked in the lock file and do everything locally. So there's no sort of consensus or authority left there. I may have misunderstood. I'm sorry? Okay, so given that you have an address of a contract, how do you get the source code? So in Web3, there's a method called getCode, and this is in all of the Web3s. And so it just takes an address and it gives you back the byte code at that address. So this is sort of a built-in part of the Ethereum network is you can directly access the byte code. The source part is you're still going to have to find that somewhere, right? You're going to have to find, like, whoever is offering, you know, whoever posted the contract is going to have to make the source available. So it's still, this doesn't prevent people from never releasing the source, but once they do release the source, they can simply link to a lock file, and that's all you need, as opposed to giving you some, you know, long list of things that you need to validate.
Thank you very much. Sorry, yeah, you just
okay.
Next speaker.
Thanks. Catch me around after or come to the workshop.